One of the major applications of statistics is estimating population parameters from sample statistics. For example, a poll may seek to estimate the proportion of people in a city that support a proposition to build a new sports stadium. Out of a random sample of 200 people, 106 say they support the proposition. Thus, in the sample, 0.53 of the people supported the proposition. This value of 0.53 is called a point estimate of the population proportion. It is called a point estimate because the estimate consists of a single value or point. Point estimates are usually supplemented by interval estimates called confidence intervals. Confidence intervals are intervals that contain the population parameter a specified proportion of the time. For instance, a 95% confidence interval would contain the population parameter 95% of the time. Continuing with the example, if the same pollster used a method that contains the parameter 95% of the time it is used, he or she would arrive at the following 95% confidence interval. 0.46 is less than the population proportion, which is less than 0.60. The pollster would then conclude that most likely, somewhere between 0.46 and 0.60 of the population supports the proposal. The media usually reports this type of result by saying that 53% favor the proposition, with a margin of error of 7%. In an experiment on memory for chess positions, the mean recall for tournament players was 63.8, and the mean for non-players was 33.1. Therefore, a point estimate of the difference between population means is 30.7. The 95% confidence interval on the difference between means extends from 19.05 to 42.35. You will see how to compute this kind of interval later in this chapter.